today's Leetcode question is number 2096, step-by-step directions from a binary tree node to another. It's medium, and let's read the directions. You're given the root of a binary tree with n nodes. Each node is uniquely assigned a value from 1 to n. You're also given an integer start value representing the value of the start node s, and a different integer destination value representing the value of the destination node t. Find the shortest path starting from node S and ending at node T. Generate step-by-step directions of such a path as a string consisting of only the uppercase letters L, R, and U. Each letter indicates a specific direction. L means to go to the left child, R means to go to the right child, U means to go to the parent node. And you want to return the step-by-step directions of the shortest path from S to T. So for example here, you want to start at 3, and you want to end at 6, so you go up, up, right child, left child, so the output is UURL. And then here you start at 2 and you want to end at 1, so you go 2, 1, which is to the left child, so the output is simply L. And then there are at most 10 to the power 5 nodes, so we should be looking for like a n log end or linear solution. I don't think the node value range really matters. All the values in the tree are unique. And the values are within n, and they're not going to be the same node. Okay, so first we look at the problem, and we need to be able to find like the shortest path from between two nodes. And the easiest way to do that is just to figure out what the common ancestor is. So we would probably have to do like a DFS of to find the nodes. And if we find the node, we want to like figure out, okay, we need to find the common ancestor of the two nodes, right? So we should keep track of every node that we have to go through to get to each particular node, and then using like those two lists of all the nodes, we can trace back and find like what the common ancestor is, if that makes sense. Okay, so I think how to do this, we just have we can have like a DFS thing here. And the DFS is just going to take in the current node. Let me think. So we need a way to also keep track. Okay, I think we just do something like per path equal to nothing. I'm just going to rename this DIRS for efficiency. Okay, so the way this is going to work is we're always going to keep track of the current path. So for example, for 3, we'd go 5, 1, 3, so the path would end up becoming okay, so we would always keep track of the current path. So for example, if we're at 1, the current path would be 5 to 1, or if we're at 4, the current path would be 5 to 4. And if we reach the given node's start value or destination value, we want to copy over that to the current path to like that specific path. And then we can also keep track of the directions as well to keep track of whether we went left or right. So we can just do if null, or if it's equal to none, we can just return if cur is equal to cur dot val is equal to start value. We just do start path is equal to current path copy. Okay, we should add the current stuff to cur path. So we do cur path dot append cur value, and then for the directions, it's gonna be for the next one. So what I mean by that is like if we're at 5, we're gonna have 5 in the current path, and current directions is gonna be empty. But once we go to, like, for example, 1, before we go to it, before we call DFS to go to 1, we're gonna push L onto directions. So we can do that. Start path is create path dot copy. Start deers is equal to cur deers dot copy. Okay. And then we can just do if cur dot value is equal to end value. Where's destination value? And do rename these to destination for consistency. And do dest path is equal to cur path dot copy. Destination directions is equal to cur dot copy. Okay. And now there's 2 DFS things that we can do. We can either call to the left child or to the right child. So if we go to the left child, we want to first do characters dot append L, and then we can do DFS cur dot left, and then we do characters dot pop characters dot append right DFS cur dot right characters dot pop, and this should hopefully populate everything correctly. Let's just test it first. Okay, so if we look at the standard out, everything's empty, so I guess we did it wrong. We can check this. Huh, so I guess we never go into that. Oh, I'm stupid as hell. Okay, I didn't even call the freaking function. That's root. Okay, and now we're gonna get a compiler. Yep. Oh. Yeah, you know what? I also want to make sure to pop cur.value when we're done with it. Oh my god. My typos are everywhere, huh? Uh-oh. This is not good. It does look like... Oh, you know what? It's because it's like an inner function, so I think I have to type like at non-local or something like that. How do I even do that? Let me go figure that out. 1 second. Do this. Pretty simple. What? You might have to put it in like a declaration maybe? Hold on. Okay, yay. This works. 526. All right. Okay, code's a bit messy, but does look like it works. See this? 2, right, 2, 1. Let me just go left. All right. Now let's think about how we want to do the rest of it. Okay, we can probably just traverse down each path list left to right to find the location of the common ancestor. Because if we do right to left, it might be like mismatched. But left to right, we're always going to be able to find the common ancestor at like the same index. So for example, like in the second case, the path to the common ancestor is like it's the last index for the start node, but for the destination node, it's 1 from the last index. So we would have to traverse forwards to find it, but if we traverse backwards, we would hit 2 here and then 1 here. And then if we go backwards again, we wouldn't hit anything here. We would have to go back to 2. So it's like mismatched. It's just harder to do. But if we go forwards, it would be easier. Let's see, how do we do this? We can probably just do annoyingly, we would also have to do this after. Maybe there's a more elegant way to write it. But yeah, this should give us the ancestor node. And then from the ancestor node, we could just do okay, first we have to put in Okay, so from the start node, there's 2 possibilities, right? Either from the start node you have to go up to its parents, or the start node is the ancestor node. So you would or it is the ancestor. So you would have to go down like in the second example. So those are the 2 possibilities. We can just think of it as we keep going up from the start node until we reach the ancestor. That way, if we just immediately go down, yeah, okay. That way, if we just immediately go down, okay, I forgot what I was talking about. Honestly, I'm thinking through this. But yeah, we can just do this is gonna be like the final answer list. We do while or we can just do this maybe. P times okay, let's look at these. So say for example here, we have the common ancestor is at 0. So we do 1, 3, so there's 2 here. So it's a length 3. 3 minus 1. You know what? Here's this way's more elegant. We can just do that, and then we do a length of start path minus ancestor. So for example here, Is this gonna work though? No, I don't want to be messing with the bounds like that. So, because ancestor isn't just limited by this, it's also possibly limited by these, which it shouldn't be, but like, it could. I don't want to think through it right now. So we could just do a ancestor plus 1, or we do ancestor minus 1 of start path minus. Okay. So here the length of the start path is 3. Ancestor is going to be at 0. So it's going to be 3 minus 0 minus 1 is equal to 2. And that's how many parents there are. And then in here, ancestor is going to be at 0. Length of start path is going to be 1. So it's going to be 1 minus 0 minus 1, which is 0. And that's the amount of p's we want. And then we can just do gears.append. Actually, I don't know if you could do this with lists in Python. But I was just going to append like the slice of another list. We can try it though. It's destination path. So now we want the moves that would take from the destination path to the end. So here, ancestors, I think we could just do this. Let's see. So here, ancestor is at 0, so you do 0 to the end. Okay, seems like it works. I just need to check the syntax. But after that, we could just return this .join gears. Will the syntax work? Uh-oh. Do I have an infinite loop here? Why is it taking so long? Why is this taking so long? What the? I don't think this should be an infinite loop. Okay, wait, ancestor start path. Like these bounds don't really do anything. I am incrementing ancestor. Is Leetcode just down or something? It was down earlier. Because like normally I would be timed out at least by now. Okay, I'll just start recording again when this thing loads. So the network was being a bit wonky, but now it's back up. And I did fix a few things. So first of all, stupid mistake. The parent directive is not P, it's U. And then for the for appending a slice of or like concatenating a list together, you just add them together. You don't have to do append or anything. That would just append the whole list at the end. So yeah. So these two test cases work, but I want to try one more test case, which is where the start value is actually the direct child of the destination value. I think that's like the one thing that we haven't really done yet. So we can try that and run it. All right, it does work. I honestly think the logic is pretty solid. Of course, there's some syntax errors, which I'll have to practice a bit more on. But if we submit it, let's see if it works. Uh-oh. How long this is taking is not a good sign. Or maybe Leetcode's just down again. Let's hope that's the reason why. Yeah, you know what? I'll just stop recording again. I'll re-record. Well, I'll re-begin recording once this thing has successfully submitted. It's finally back up, and I did have a successful submission, but unfortunately I am once again behind the mode of people. Wow. See, this is what I mean by elegance. This is so much more elegant than my solution. Oh, they just used they DFS twice. You know what? I was gonna say my solution is still more efficient because I only DFS'd once. But then, if they did, they still did a better, empirically speaking, with their runtime 255 versus 317. So I guess I can't even say that. But yeah, so this is more like a, just like keeping track of stuff method. Oh, well, this is definitely way more elegant than the way I did. Wait, what did they even put onto path? Just L and R? Oh. Oh, you know what? Okay, I completely overlooked something, which is that L and R, like, if the common ancestors are the same, like for example, let's say that 1 or 2 is the common ancestors of our nodes, right? So both of their directions are gonna go R. So we don't even need the paths list. That's just an oversight on my part. I think they just did that. Oh, this is okay. This is an interesting way to join everything together. Or let's look at the solutions. 3 steps. Oh, never mind. It's just the same thing. All right. Well, I guess I'll have to continue working on my code's syntax and elegance implementation. But yeah. Well, I'll be back for tomorrow's daily question, and thank you guys for watching. Bye bye.